about the factors affecting the bond length. The second one is hybridization mode. The mode, what is hybridization mode here? Hybridization mode basically means the more the value of S or the extent of S, the less with the bond length. Here the S characteristics is basically dependent on the S characteristics. So the value of extent or S characteristics is inversely. So let me write it again here. Okay. So S proportional is inversely proportional to the bond length. We can demonstrate that is here as well. For example, let me move here. We know that sp3 I'm only writing the hybridization, which is sp2 and sp. The value of S characteristic in sp is 50%. 50. While in sp2 it's 33. While in sp in sp we have it's 50, 33, and the other is 25 respectively, right? So this is the values of the S characteristics, right? Now I'm gonna make here the ethene and ethine here, so it will be more clear to you. I'm going to let me brush it. Right. So this is carbon with single bond ethane, carbon with double bond ethene, carbon with triple bond ethine. Okay, this is only a rough diagram, so ignore it, right? So here the hybridization is sp. Here the hybridization is sp2. Here is sp3. So we know that sp3. Here the extent of the overlapping is 50%. Not extent of overlapping with the S characteristics. Here we have 30%, 33%. Here we have 25%. So the more the value of S, the less with the bond length. So here the bond length of carbon with triple bond is very least. It has less bond length, or its bond length is large in size. This is because due to presence only one single bond. Right. So this is about the hybridization mode. Now I'm going to talk about the next factor, which is atomic radii. Let's move it. Now I'm going to talk about the next factor, which is atomic radii. Atomic radii. Now what is atomic radii? Actually, atomic radii is the size of the it is basically a distance from one nucleus to the other nucleus of a bounded atom, right? So atomic radii is directly proportional, or is directly. Now I'm going to write it directly proportional to bond length. The more the atomic radii, the more the bond length. Right? We can demonstrate this as well. Here I'm writing 4 group. Here I'm writing 5 group. First of all, I'm writing the 4th group. 4th group. Fifth group. Here, right. So here we have carbon, silicon, germanium. Germanium. Then here we have nitrogen and phosphorus. Consider for a while that carbon has only we know that it does not have only one orbit, but for a while we can consider as one orbit, but silicon has 2 orbits. We know that the atomic radii decreases down the group. So as you can see, that as the number of atomic radii increases, which means the more with the size of the atom, with the overlapping atom or the bounded atom, the more will be the bond length, right? And so as for the nitrogen as well. Nitrogen bond length is less than the phosphorus, right? Now I'm talking about the hydrogen halides. Hydrogen halides. Okay. So what is hydrogen halide? Which is fluorine. Then we have chlorine. Then we have bromine. Then we have iodine. So their bond with the hydrogen is known as fluorine. This is chlorine, right? Mistakenly I have written here. So this is chlorine. Chlorine, bromine, iodine. Their bond with the hydrogen is known as hydrogen fluoride. HF. Then we have fluorine. Then we have HCl. Then we have HBr. So they are bond. HBr. Oh my god, I'm making a lot of mistake while writing it. Okay, so HBr and then HI. So it has very small atomic